So today I will start with electron transport chain. So this electron transport chain, as you people may know, that this is the source for high amount of energy. High amount of energy. And this high amount of energy occurs in this process inside the mitochondria. Takes place inside mitochondria. Mitochondria has got an outer mitochondrial membrane. Outer membrane, mitochondrial membrane. And it has got an inner mitochondrial membrane, which is folded. It has got an inner mitochondrial membrane. Inner mitochondrial membrane, outer mitochondrial membrane and inner mitochondrial membrane. And this outer and inner mitochondrial membrane, this inner mitochondrial membrane is folded into finger-like structure known as vestige. And on this mitochondrial structure and the space in between, this is the intermembrane space. This is the intermembrane space. And on these are present all along, these are the enzyme complexes of the electron transport chain. Enzyme complexes of the electron transport chain. So who are these complexes of the electron transport chain? They are the complex 1, complex 2, complex 3, complex 4, and the 5th complex, it is known as ATP synthase. And there are complexes NADH, ubiquinone, oxidoreductase complex. This is NADH, ubiquinone, oxidoreductase complex. Complex 2 is the succinate dehydrogenase complex. And complex 3 is the cytochrome C reductase. Cytochrome C reductase. Complex 4 is cytochrome C oxidase. These are the four different enzyme complexes which are present and which you must study. Now the reducing power which was obtained in the metabolic cycle, glycolysis, secret cycle, fatty acid oxidation, etc. in the form of NADH and FADH2 and FADH2. It is utilized for ATP generation. It is utilized for energy generation. This is the function of the electron transport chain. And now in glycolysis what happens? Here, 2 NADH, 2 H plus is formed. Right, in the pyruvate dehydrogenase complex. In the Krebs cycle, 3 NADH plus 3 H plus. 16 carbon beta oxidation, 16 carbon fatty acid. I will take this also later. 16 carbon fatty acid oxidation. You will also have, here you have more. 16 means you will have 7 NADH plus 7 FADH2. All these reducing powers which are formed in this particular pathway, this is utilized. One more thing, this NADH when it breaks up, it forms NAD plus plus H minus. Now this H minus when it loses 2 electrons, H minus, this is the hydride ion. is the hydride ion which is formed. When it loses, it forms H plus two electrons, two high energy electrons. This energy in these two high energy electrons, by the way, dehydrogenous complex, CDH. This two high energy electrons, the energy is taken from these two high energy electrons and this is utilized. It goes gradually from one enzyme to the other enzyme to the other enzyme to the other complex. One complex to the other complex to this energy, high energy electron, it goes to this complex. Some energy is lost. Sorry, it goes to complex 1, say it goes to complex 3. Some energy is lost. Then from complex 2 also it goes, some energy is lost. Complex 3 to complex 4 also some energy is lost. Now this energy which is lost, that is used to pump H plus from inside to the intermembrane space. This energy is utilized to pump H plus. This is the mitochondrial matrix. This is the mitochondrial matrix. This is used from the mitochondrial matrix on H plus from matrix to intermembrane space. Pump H plus from matrix to intermembrane space. This is its function basically. So result what will happen is high concentration of H plus of proton is formed. Concentration or H plus or proton is formed. Where is it formed? In the intermembrane space. A high concentration of forms. And now what it does is, there is this dynamo of ATP synthase complex. So what happens? H plus enters from here inside. In that process, this rotates. ATP synthase rotates, works like a dynamo. And this energy, when it rotates like hydraulic power plant, this energy is utilized to make ATP from ADP and PI. And this H plus, which is coming inside, has to be removed. And there you need the molecular oxygen. So you need half of O2 plus the H plus to form H2O. Half of O2 মানে and one molecule of oxygen. Basically this thing happens. And ADP plus CI, it forms ATP. Energy from dynamo moving. This is what happens in the whole of the electron transport chain. These are the steps. Now we will go up to the individual complexes. ঠিক আছে বুঝছি বুঝছি Now the first complex is NADH ubiquitin oxidoreductase complex. Complex 1. NADH ubiquitin NADH ubiquitin oxidoreductase complex. Oxidoreductase enzyme complex. It's a complex of several enzymes. The basic function is this. It's like a gun. First, you can find the structure something like this. And you know a hydride ion first thing. H minus, like I said, this comes from NADH breakdown. Two high energy electrons. This remember. Now what happens here is NADH in contact with this enzyme it becomes NAD plus plus H minus. H minus right, and these are the two high energy electrons. This electron, two electrons they go to a complex known as SMN complex, flavine mononucleotide complex. This goes to an iron sulfur complex with 2 electrons. Iron sulfur complex. At each step, the high energy electron loses some energy. It is utilized to pump H plus out. Now from here, it goes to an N2 center. It's also another iron center. N2 center. Then these 2 electrons, there is quinone, there is a molecule Q, and it will take 2H plus from the mitochondrial matrix. This is the intermembrane space here, and below this is the membrane, and below this is the mitochondrial matrix. Q will form QH2. It will take the electron, and at the same time, this energy which is used, which is generated, it will pump out 4H plus. Aim being to have more H plus in the intermembrane state and less in the mitochondrial matrix. So basically, the energy which this loses, that is going to be used to pump protons out. So basically 4 protons per electron pair. So basically 2 protons go over here. So basically something like 6H plus is pumped outside because of this. And the energy from this to this, some energy from the electron is lost. Electron excited state है, jump कर रहा है हमेशा. धीरे-धीरे jump कम हो रहा है. And that energy is being utilized and it is used to pump the protons outside. This is the next function of the first component. Okay? Okay. Now this QH2 which is formed, it goes to complex travels to complex 3. Now the electron is stored in QH2. QH2 is secondary electron. QH2, Q has secondary electron. with two protons, and this electron now is stored in QH. Higher, less energy, but still there is some energy there. अभी भी दम बाकी है, लेकिन पूरा दम नहीं. Now, the next complex is the famous complex 2 or the succinate dehydrogenase complex. Is the complex 2 or the succinate dehydrogenase complex. This is also second আসছে না, second এর QH কে কিছু করার কিছু নেই, খাওয়ার লোক নেই, খাওয়ার লোক না, খাওয়ার লোকের কাছে যাচ্ছে, সব জায়গায় ছেড়ে দিচ্ছি খাওয়ার লোককে। রিসেপ্টর যদি না থাকে কি করবে QH? কেন এটাও QH আরেকটা QH ছাড়বে, এটা একটা প্যারালালি দুটো দুটো জায়গা থেকে এনার্জি দিচ্ছে, মানে complex 1 is utilizes NADH and complex 2 utilizes FADH2. So this succinate dehydrogenase is also the enzyme in the Krebs cycle. Succinate থেকে malate. So let's look at the structure. Something like this it looks. Succinate থেকে malate goes fumarate. This is a step of the Krebs cycle which is taking place. Succinate থেকে fumarate. What is generated? FADH2 is generated. FADH2. Now what happens? Two electrons are also released with hydrogen. There are three iron sulfur centers. The electron passes the high energy electron passes through these three iron sulfur centers. It loses some energy on the process, of course, and this electron finally it finds another Q plus 2H plus 2 electron. This is from another QH2, and this QH2 will again travel to complex 3. It will again travel to complex 3. So complex 1 say it's going, and complex 2 say it's going to complex 3. Some QH2 molecules are going to complex 3 from all these two. So this is working parallelly. This is utilizing FADH2 and that is utilizing NADH plus H+. Right question. Now we go to the complex tree. Cytochrome C oxidoreductase, cytochrome C reductase. The cytochrome C reductase. Now there are two centers. Q0 center, QI center. Now two QH2, two molecules of two QH2 will form 2Q, and it will form four protons out. Two are the four hydrogen atoms here. Four protons formed out. And one QH2 had two electrons, so four QH2 will have two QH2 will have four electrons. So four electrons are released. Two electrons out of that will go in one pathway, and two electrons will go in another pathway. Let's see the lower pathway. This will go to a center known as Bl center, iron center. Again, the two electrons will go to a heavy center, iron. From there, the two electrons will go to the Qi center. Here, it will take a Q, it will take a 2H plus, 2H plus 2 electrons and form another molecule of QH2. Ready for another recycling. Okay, two electrons. The other two electrons will go to a iron sulfur center. FES. Then it will go to the C1 center, cytochrome C1 center, the real enzyme center. What it will do, it will convert these two electrons to cytochrome oxidized, two molecules of cytochrome in the oxidized form. It will take this, it will take two and two electrons, gain of electrons and form two cytochrome reduced. This is the function. To reduce cytochrome is formed. Now these two cytochrome reduced will go to complex 4. So you can see inside protons are reducing, H plus come हो रहा है and in the intermembrane space it is increasing. So today I will stop because it's getting late. I have to go for a meeting. Okay. The next day I will come to the next two cycle things. Bring this notebook also, which you are writing. It will help you.